Welcome back to lesson 7 for Year 11 Physics, Double Science. Good news is you've completed all the learning objectives for this first topic. So this lesson is a summary where we are going to be applying what you've learned, the learning objectives, and looking at some exam questions, GCSE, past paper, exam questions. Please make sure that you've completed the starter retrieval quiz before watching this video and completing the pages in the booklet. Just for you to know, in terms of what we're going to be covering today, we're going to be completing pages 35 to 38, which will be the end of the booklet. Let's start with this first exam question, and this is one that I'm going to leave for you to do. I have made a quick start underneath. Really important, of course, to make sure you take time to read the question carefully. And this one, you've really got to take your time reading it, because when I've read this through the first and second time, I didn't quite know what to do. So I had to read it a third time, so it made sense. So let's go through it. The highway code provides information about stopping distances. And it just gives a recap there on what stopping distances are in terms of thinking and braking. Remember, a stopping distance equals thinking distance plus braking distance. So for example, if the thinking distance was 10 meters and the braking distance was 30 meters, the overall stopping distance would be those two added together, giving you 40 meters. Okay. Now, underneath, it gives a table. It says the overall stopping distance is divided into two parts, thinking and braking distance. We just looked at that. Some of the factors which affect the overall stopping distance are shown in table 10.7 below. I've just highlighted those in 3 colours, and I'll explain why in a moment. Choose one. Look at this. It's a 6-mark question. So it's not going to be a 1 or 2 sentence answer. You've got to try and work out what would be in the mark scheme to get those 6 marks. And if you look underneath, you'll find the clues. You've almost got to be like a detective to work out what you'd get those 6 marks for. And remember, in these 6-mark questions, you'll have 1 or 2 marks will be for the quality, QWC, quality of written communication. That's your SPAG, or spelling, punctuation and grammar. So what have we got to have in the answer? What's the success criteria? It says in your answer include the following: the 3 factors you have chosen. For each factor, refer to the thinking distance, the braking distance and overall stopping distance, and describe clearly whether these distances are increased, decreased or unaffected. You've got to choose one factor from each column. So A, B and C. I've chose, well, there wasn't much of a choice in the first column, was there? The first column tells you which factor to choose. In B and C, B for example, you can either choose condition of brakes or road surface conditions. It's up to you. Let's look at column A, speed of vehicle. This is what I've written down. As the speed of the vehicle increases, keywords increases, so does the stopping distance, the braking distance and the thinking distance. Now what you've got to do is that same thing, a sentence or two describing if we pick condition of brakes, for example, you could say, if the condition of brakes are poor, this will increase the braking distance. So I'd use that word there, increased. It would not affect the thinking distance. I could say that a different way. I could say the thinking distance is unaffected, and it would increase the overall stopping distance. So I've just put 2 red asterisks underneath and highlighted in green and purple, relating to the green and purple columns there. So that's page 35. If we go on to page 36, I've read through this one, and I'm sure you'll all be able to answer that underneath if you just take your time, read the questions carefully, think, read it 2 or 3 times. If it doesn't make sense, please don't rush. Underneath, moving on to page 37. A bit more challenging, this question. So I've scaffolded this one for you to make a start. Question 5, it says a car is travelling 15 meters per second and decelerates to 0 in 5 seconds. Select and use an equation to calculate the deceleration of the car. Answer this on the right hand side as I've shown there. I've made a start. I've chosen the equation for you. Then you should be able to part B. Oh, it's not part C, is it? I'll just change that. Part B, 1 and 2 underneath. So 1 is a calculation and 2 is an explanation. Again, look at the number of marks you get in these exam questions. This is an exam question from 2014. So you have to make 2 points there for the explanation. Let's have a quick read through. It says, explain how the mean speed of the decelerating car travelling at 15 meters per second would have changed, if at all, if the road had been icy instead of dry. If you think of that, if the road condition is icy, it's going to have a longer braking distance. So think about that when you give your answer to that explanation. Question 6, underneath. Here, the important point, the key point here, is understanding at what point the car driver applies the brake. So I've just added an arrow and an annotation to help you. It's saying the car's moving at 15 meters per second. I'll highlight and delete in a second. So this is where the car's moving at 15 meters per second. It says a child runs out into the road, causing the driver to make an emergency stop. So it's at that point there where the line goes from horizontal and starts decreasing in speed. At that point there where the brakes are applied. Now, what it's asking you to do is to work out the reaction time of the driver. Now, to work out the reaction time of the driver, you're going to have to use the scale of the graph, because what's happening is at this point here, let's change the pen, beg your pardon, let's change the pen. At this point here, I should say, that's when the driver sees the child run out onto the road, and at this point here is when the driver has reacted and applies the brakes. So use the scale underneath. Use a ruler would be a good idea. You can see it using a ruler, it helps you work out exactly where on that scale the brakes are applied. So moving on then, if you finish that question, make sure you give good detail again in the explanations here underneath. The final question, the final page in fact, on the booklet, page 38. 3 parts to it, A, B and C. First part is a 6 marker again, so good detail required in that description. Now when you answer this, if you break down the answer into chunks or sections, it will really help you get those 6 marks. It's asking you to describe the motion of the bus during the 70 seconds. So you could break this up into let's get a highlighter on, 1, 2, 3 and 4 different sections. And in those different sections, you had a written assessment like this back in lesson 3 when you looked at distance time graphs. Remember, this is a velocity time graph. So for example, a horizontal line is not stationary, it means constant velocity. So if I were given a quick verbal description of this graph, I would say for the first 10 seconds, is it a bus? Yes, a bus is moving at a constant velocity of 5 meters per second. Between 10 and 20 seconds, the bus is accelerating from 5 to 20 meters per second. To improve that, you could actually calculate the acceleration. Now you could work out the change in velocity and the change in time. The change in velocity there, look, 20 take away 5 is 15 meters per second, and the change in time is 10. So 15 divided by 10 is 1.5 meters per second square. You could then, I think you describe that part, and you describe this part. Oh, that's a curve, so you haven't got a linear acceleration. If you just remember, if you've got a straight line, that's a linear or constant acceleration. Here, the acceleration is changing because the gradient of the slope is changing. You can see that the slope is steeper at the start, here, at 50 seconds, then the gradient is getting less and less, showing that the acceleration, or in this case, the deceleration, is getting less. That's part A. Part B. During the first 10 seconds, the bus travels 50 meters. Use this information to construct a distance time graph for the first 10 seconds. Now, just to help you with this, I've just drawn out some axes underneath. Simple axes going up to 10 seconds, distance going up to 50 meters. And every second, the bus is traveling. Well, it's the first part. It's looking at the first 10 seconds. So let's highlight the first 10 seconds is this here. And what that's telling us is that for the first 10 seconds, the bus is traveling at 5 meters per second. Convert that green highlighted section into its own distance time graph for the first 10 seconds. And if you plot, I've done the first second there, so it's 5 meters. 5 meters will be there in the first second. Another 5 meters in that second. I think you'll work it out from there. That's part B. And then finally part C. Calculate the distance travelled by the bus between A and B. So A and B in this occasion is obviously that part there. And go back if you can't remember how to do it. Work out how to calculate the distance travelled. There's 2 ways of doing it. You can use that equation, that's the simplest way, but also you can calculate the area underneath that section of the graph. And there we go. That is the end of the first of 5 topics for Double Science Physics. Please make sure you've completed the booklet. If you haven't, go back through the previous lessons and videos, and look forward to seeing you in the next topic. Bye now.